All right, everybody, how's it going? So today we're going to talk a little bit about the nature of science and scientific methods, or how we conduct science. So let's get started. If we talk about what science is, I think one of the most simple ways of describing or defining science is it's just a way of knowing. So it's a systematic process where we can use observation and experimentation to study the natural world. Science is a dynamic process. It is more than just a collection of facts. It involves questioning, using critical thinking. It's a creative process. So there's a lot that goes into it. And again, it's just one way, a very powerful way of knowing and learning about our natural world. If we look at some types of science and kind of start here, we could say that discovery science is kind of a type of science that relies on descriptions. So making careful observations about the natural world, and then, of course, analyzing those observations to try to make sense. So a basic definition here is, what is an observation? And observation is just using your senses to gather information about the natural world. So observation is necessary for science. It's kind of the foundation. If you can't observe something, then you can't use science. So pretty much all science starts with observation. When we talk about observations, we write those down or we collect those to analyze them. We call that data. So when we record our observations, like in a lab you would do in the science classroom, we've all collected data before. Now, observations or data can be two different types. If we talk about observations or data that are descriptive, so qualities, think about that word qualitative, like qualities. You could say something like it's soft, it's red, it's smooth, it's round. So these are going to be ways of describing something in words, so descriptors. The other type of observation or data would be quantitative. So think about quantitative as a quality, right? A quantity, an amount. So these are going to have numbers. So quantitative observations are going to be like 5 centimeters, 25 grams. These are going to involve numbers and they will have a quantity, right? Another foundational part of science is understanding the difference between observation and inference, right? So we've described an observation as just using your senses to observe the natural world. And inferences kind of follow observation. And humans are pretty smart. And so we make inferences naturally based on our observations all the time. It's how we make sense of our world on a daily basis. So an inference is just making a conclusion based on your prior knowledge and the observations that you are making as you navigate your world. Let's practice. If you look here, it's showing you a comic strip, and if you couldn't make inferences, you wouldn't find this funny. Maybe you don't find it funny anyway. But if I was to look at this, I could say, okay, I'm going to make a couple of observations. Well, I could say there's one cat, there's one dog. I could say there's one washer and one dryer. I could say the cat has 1, 2, 3, 4, 5, 6, 7, 8 stripes. And, if I was to go further than that, I could make some inferences based on that. So some inferences I could make here would be that the dog is trying to kill the cat. I could say that the dog wrote incorrectly cat FUD on what looks like the dryer there, right? I could say that the dog is hiding from the cat, right? So I take my observations and then, of course, put them together and make inferences. And, if I couldn't do that, this would probably not be funny. So observation versus inference. Now, sometimes it's not enough to describe. We actually want to explain. And when we want to do that, we're conducting what's called hypothesis-based science, right? And so this is when we're trying to go beyond just descriptions, but actually explain. So with these, we would actually be formulating a hypothesis, which you might remember is just an educated guess based on your past experiences and the available data. When we look at a hypothesis or an educated guess, there's a couple of things we need to remember that they need to contain. A good hypothesis has to be testable. In other words, if you can't test it, if there's no way of testing your hypothesis, then it's useless, right? It has to be falsifiable. You have to be able to prove it wrong, right? If we can't prove a hypothesis wrong, then it's not really usable. And this is why science is relegated or limited to the natural world. If we're trying to do supernatural things that we can never test or prove wrong, then it's not really going to fit within science. The last thing about a hypothesis to understand that your hypothesis, even if it appears to be supported, they're never proven to be correct beyond a shadow of a doubt. There's always going to be levels of certainty and certain variables that we could never account for. So we have some that are more certain than others, but remember, it's never proven beyond a shadow of a doubt. You're actually trying to disprove your hypothesis, and remember, it has to be testable. So scientific method, this is something you've been learning probably since second grade, and sometimes you'll see it with 7 or 8 or 6 or 4. We're going to go with 5 basic steps. This is really not something that any scientist is using. It's a way of kind of teaching you how to think scientifically or how to kind of carry out scientific processes. So the first step here would be, of course, observation. So you're going to collect information or observations about a natural phenomenon, and from there, you're going to start to ask questions, right? So how does this happen? Why is this occurring? What will happen if I change this? So those questions, of course, allow us to start to formulate hypotheses. And then from our hypotheses, we can make predictions, right? So if I am correct about my hypothesis and I change this, then this should happen. From there, we're going to make what's called a controlled experiment. We'll talk about that. So it's just a systematic way of doing testing your hypothesis. And then we're going to, of course, take our data and make our conclusions based on our results. Again, this is more a teaching tool than anything. If we go from here, we will see that we're going to talk about a basic example here. So I want to give you a silly kind of example just to keep it kind of simple and straightforward for you. So we're going to use the example of a person that can't get a date. So here's my observation is I'm not able to get a date for Friday night. And from that, I can say, okay, well, I can formulate a question. And my question here is going to be, well, why can't I get a date for Friday night? So 2 things, that's my starting point. From there, I'm going to make a hypothesis and I'm going to make a prediction. So my hypothesis here is that my body odor is preventing me from getting a date for Friday night. So I'm a sweaty beast. If I use that as my hypothesis, I can then make a prediction. Remember, that's usually if then. So if I wear perfume or cologne, I will get a date, right? So that's a very testable, easy experiment to run. And if it works out, this is what my hope is. Next, we're going to set up a controlled experiment. So a controlled experiment, you guys, is just a planned procedure, a way of testing your hypothesis. And so a controlled experiment contains 2 groups. It contains a control group and 1 or more experimental groups. So what's the difference between those 2? A control group is a group in an experiment that does not receive any experimental treatment. It's not receiving, in the case of my experiment here, cologne. And so control groups are for comparison. You have to know what normal is so that when you make changes, you can compare those changes to the normal or control group. The experimental group, on the other hand, does receive the treatment. In this case, our treatment would be they would receive, or I would receive, cologne. So our experimental group is receiving some type of treatment, whereas the control group is not. The control group is for comparison with the experimental group or groups. All right. Again, we only want to test one factor or one variable. So everything between these 2 groups should be identical except for one variable. The one variable in my experiment here would be cologne. Everything else is the same. So the same, person, same hairstyle, same clothes, whatever it might be, but we're only changing one variable. Now, when we set up our experiment, you guys, a couple things. First of all, we want to make sure that when we're doing an experiment that we have a good control, right? So you need a good control in order to make sure that your experiment is valid, right? Remember, a control is going to allow us to make comparisons. Must be repeatable. So your experiment should be repeatable. If we carry out an experiment and somebody else carries out that same experiment, follows our procedures, they should get the same results. And finally, we want to make sure that we're avoiding bias, right? We don't want to let our hopes that our hypothesis is correct impair our judgment, right? So we've got to make sure that we're not using personal opinion and that we're following what the evidence actually shows us in the data. So let's talk about the parts of an experiment that we see. So there's some different variables here that we can talk about. So in an experiment, first of all, there is what is called the independent variable. And this is the factor or the variable in the experiment that you, the experimenter, are purposely changing. So you change this, I change, right? So I change something in the experiment that is being manipulated. Now, the other variable that we look at is what's called the dependent variable, or the DV. And the dependent variable is the factor that changes as a result of the independent variable. So the dependent variable depends on the independent variable. An easy way to remember the dependent variable is if you just remember that the dependent variable is what is being measured in the experiment. It's what you're measuring. So I'm manipulating the IV, I'm changing something, and then I am measuring the dependent variable, what's happening as a result of my change. If we look at drawing conclusions here for our last step, so once our data are collected and analyzed, we need to make a conclusion. We need to try to interpret our data. And so a hypothesis can either be supported or it can be rejected. In the case of my silly experiment with the cologne, if my hypothesis is supported, then I should have a date for Friday night, right? So if my addition of cologne was successful and my hypothesis is correct, I should have a date. If, on the other hand, my hypothesis was not supported, then I would probably be lonely on the Friday night. So I would have to reject my hypothesis, right? So back to the drawing board I go. So the last couple of things I want to talk to you about here are theories in science. So a theory, you guys, is a very powerful thing in science, and it is basically a summarization of a group of several related hypotheses that have been supported repeatedly with multiple testing. Theories are a way of explaining, and that's an important way to remember. If you remember that theories explain phenomena. Theories can change. Theories do change. So as we learn more about a particular phenomenon, or as we gather more evidence, we have to kind of recalculate or reformulate our theory to fit the new data, right? So theories are constantly changing. If we look at laws, these would be scientific laws, and these laws are going to be summarizing observations. So laws take multiple observations about what we think will happen based on what we have observed in the past. And so laws are more descriptors. So they describe observed phenomena. They describe what we're seeing in nature. So laws like the law of motion or the law of conservation of matter. So again, we're not really explaining with these laws. Laws, if you'll just remember, are going to be a way of describing phenomena. So that's kind of a look at what we are scientific investigation or nature of science. And so obviously these are posted. You can go back through these. We'll be doing a lot of practice with you all to help you kind of be comfortable with these. And that's what I have for you today. So we'll see you again soon.